Hello, everyone. Can you hear me? Yep. Hi. My name is Ori Wallenstein, and I'm VP Product at QEDIT. I'm very happy to be here today. And today I will discuss that when businesses consider adopting blockchain, they bring a set of requirements that is very different from the set of requirements for a public blockchain. And the same holds true when they consider using zero-knowledge proofs as a mean to preserve transactional privacy on the blockchain. I will present QEDIT's enterprise solution for preserving transactional privacy on the blockchain using zero-knowledge proofs. And I will deep dive into some of the features behind this solution and highlight how they were tailored for the specific needs of businesses. So I'll start with something that may seem very obvious. The enterprise blockchain is not the same as the public blockchain. Now, it may seem obvious, but I think it's worthwhile to discuss just how different the two really are. It's not simply a matter of taking a public blockchain and having permission control over who can join it and what role they have. It needs to cater to a very different set of requirements and constraints. Let's consider some of these requirements and see how they differ in weight or in essence between the two cases. So let's start with privacy. Businesses put a lot of emphasis on preserving privacy. We know that public blockchains, cryptocurrencies, have flourished for many years without any transactional privacy, really, and just having pseudo-anonymity. Enterprises, on the other hand, when you look at enterprise use cases, when they want to transfer assets on the blockchain, maybe manage a supply chain, as we saw in some of the presentations earlier, there are very few use cases that work if we cannot ensure the confidentiality of transactions. In a public blockchain, anyone can join the blockchain. So it faces a much wider range of possible attacks, much wider range of possible adversaries. And so it needs to handle that with various algorithms. Enterprise blockchains, on the other hand, have greater control over who can join. And so they can opt for a simpler algorithm to handle these threats and risks. And in fact, they do. Often, they use a very simple proof of authority, and they actually have zero mining rewards. In a public blockchain, trust is established between the players solely through protocol and code, software code. Enterprises, businesses, on the other hand, are also bound by laws, regulations, audits, their own brand reputation that they want to maintain. And all of these enhance the trust between the players. Trusted setup, we heard about this in many of the presentations today. So in a public blockchain, that's often cited as a consideration. Users want to be certain that the multi-party computation was done with integrity and correctly, and that there was no collusion between all the participants, and that there's no chance of cheating. When we talk about enterprise blockchain, this is not as much of a concern. First of all, it is feasible in many cases to actually do the trusted setup, to conduct the trusted setup with all the participants in the blockchain. Second, as I mentioned in the previous slide, this is not the only source of trust. These are businesses. They want to maintain their brand reputation. They're bound by laws and regulations, audits. So it's not solely about the protocol. So we see that you cannot take the public blockchain and just apply it as is to enterprise use cases. And it's not just a matter of adding a feature here, a feature there. It requires ongoing focus and a holistic approach that looks at all the needs, and inevitably it leads to a very different product roadmap. In fact, the enterprise blockchain is so vastly different from the public blockchain that the financial sector, for example, needs to spend, it's not clicking, there we go. It needs to spend $1.7 billion a year to use it. This is not investment money. This is R&D money put in by financial services in order to use blockchain for their own use cases. So this incredible amount shows us just how much effort is needed to adapt the public blockchain to enterprise use cases. One of the major areas of research and development is around how do we preserve transactional privacy on the blockchain. The leading method being, of course, zero-knowledge proofs. This is not working, so just click here. And this is the problem that QEDIT has set out to solve. We provide an enterprise solution that allows enterprises to transact privately on the blockchain using zero-knowledge proofs. You can transfer ownership of an asset, a token, from one party to another. And other participants in the blockchain, they do not know who's the buyer, who's the seller, what they're selling, and yet they can be certain that this is a valid transaction, that there was no double spend, all through the use of zero-knowledge proofs. Our goal is to take the standards defined here in ZKProof.org and best-of-breed algorithms and apply them in an enterprise production-ready solution. The solution provides a high-level API and several native client SDKs. And when I say high-level API, I mean that this is not a library or a set of tools for generating and verifying zero-knowledge proofs. Rather, it's an enterprise solution that provides ERC20 and ERC721-like interfaces that use zero-knowledge proofs behind the scene to ensure the validity of each transaction. So let me show you an example. Here we see a code example. It uses our Go SDK. And first we make the request. I want to transfer 1,000 tokens of asset type 200 from this wallet to this address. And then I post it, and that's it. The transaction goes through. That's all the involvement that I need. All the complexities of generating the proof, committing to the data, publishing it on the blockchain, verifying it, handling rollbacks, and so on, all of that is beautifully abstracted by very simple API calls. This allows our customers, their developers, to focus on the application layer, on their business logic, on their user experience, and all the complexities of doing the zero-knowledge proofs to verify and to validate, verify the transactions. That's handled by the services layer that we provide. I want to share with you some of the features of this solution and discuss how they were constructed specifically to fulfill business requirements. Also, I want to note that we'll see how these features are built on top of each other. One feature unlocking a new need and also laying the foundation for a new feature to handle these needs. So it's one on top of the other. When businesses consider using the blockchain, they have a very specific use case in mind, a specific business workflow. And because it's a known business workflow, they know the volume of transactions that will happen and that are needed to support. So they bring very specific requirements for throughput and for latency of a single transaction. And so in order to support these requirements, these different requirements in different use cases, we developed a method called proof chaining. What proof chaining allows us to do is to take one big proof, break it down to smaller proofs, and then run them in parallel using stateless proof generators. Separate machines, each one working on its own subproof. And the resulting proofs are then glued together through commitments on the private data that they each ran. In this way, we can reduce the latency. We can more easily support a higher throughput through horizontal scaling. And another bonus, it gives us nice modularity. So for example, let's say one of the smaller subproofs can be ran more efficiently using a different scheme, a different zero-knowledge scheme. So because these are independent proofs, we can actually run that smaller proof on a different scheme and keep the rest of the proofs with the original scheme. And then it allows us a way to further optimize the running time. Enterprise use cases usually involve multiple assets. If I'm a stock trader, I'm buying and selling many types of stocks, not just a single stock. If I'm a produce wholesaler, I'm probably buying and selling many types of fruits and vegetables. And in many cases, this could be thousands and thousands of different assets. When we think about, let's say one supply chain, it could be thousands and thousands of different possible parts and components. And having a separate interface or separate wallet for each one is not very practical. It becomes very clumsy very quickly. And so we developed our system to support multiple types of assets on the same network using the same interface. You can hold multiple types of assets in a single wallet, and that makes it more practical and easier to use for our customers. Issuance rules on public blockchain are usually very rigid. They don't change very often. And so in many cases, you see that they are baked into the code of the blockchain or into the smart contract. However, when we talked with businesses, we quickly realized that they will need greater flexibility and control over these issuance rules, how to update these issuance rules. If we were talking about, let's say, a consortium of banks, new banks will join and onboard over time. They may need to issue new assets. If this is a supply chain, one of the manufacturers may now produce new products, new parts, and they need to be able to update it. And we didn't want to do this using software forks every time, so we developed a way to define, propagate, and maintain issuance rules over the blockchain. Here we see an example of such a rule. So let's say this is manufacturer A. This is their public key. And they're allowed to issue assets from asset ID 1 to 100. So they can issue 100 different types of assets. You may have noticed this last line that says, can issue confidentially true. That means that they can issue these assets without others knowing what they're issuing and how much they're issuing. Now let's pause on that for a second. We have someone on the network that can issue assets without anybody knowing what they're issuing and how much. In a cryptocurrency, that would be considered a critical bug. But when we talk about enterprise use cases, that's not a bug, it's a feature. And in fact, it's a feature that fulfills a very fundamental business requirement. In enterprise use cases, often the details of the issuance is as sensitive as the details of transactions. So if we think about Shiri's talk earlier this morning, the Cuban tobacco farmers, if I'm one of the farmers, I don't want my competitors, my suppliers, my customers to know how much I'm producing, because that's sensitive business details. They now know how much maybe to charge me, how much they can negotiate. So I want to keep that private. And so we can see that suddenly this is a very fundamental requirement, just as privacy for transactions. So what we did, we took the issuance rules, and then on top of it, to support private issuance, we generate a range proof that shows that I am issuing assets within my provisioned range. And this proof is propagated to everyone else, and even though they do not know what I'm issuing and how much, they can be certain that this abides by a known and a specific issuance rule. Clearing and settlement of payments is often a very complex process for businesses. For example, when you buy or sell a stock, there's a behind-the-scene process that takes 2 days and involves around 10 different players, 10 different parties, until this transaction is settled and paid for. For example, many banks in recent years have issued reports that say that this process of clearing the trade of stocks costs tens of billions of dollars every year. So streamlining this process, the motivation for streamlining this process is very clear. Now, if you're just transferring ownership of, let's say, a bond or a stock on the blockchain, then you still need to finalize payment off-chain. And so you're not reaping all the rewards that you could have from the blockchain. However, if you can represent multiple assets and multiple currencies on the same network, as QEDIT solution supports, now you have the option of clearing the trade in one transaction. So Bank A is selling a bond to Bank B, and Bank B, in the same transaction, is paying for that bond using tokens representing some sort of currency. And even though the other participants, they do not know who are the two parties in the trade and what they're trading, just like any other transaction, they can be certain that this is a valid transaction, that it adheres to all the constraints and all the rules of any other transaction. Now, I want to point out how these features are built on top of each other. We have multiple assets and multiple issuers. That brings the need for more flexible issuance rules. Having issuance rules, that laid the foundation to now do private transaction. Gives us a way to verify private transactions. And because we have multiple assets on the same network, now we can do clearing and settlement in one trade, in one transaction on the blockchain. So we can see that in order to provide these features, it requires an ongoing focus. It's not just a single feature here or afterwards. It requires ongoing focus with another feature built on top of each other, all focused to cater to the needs of enterprises. And that's the path that QEDIT has chosen to take. And every day we're developing new and more features focused to deliver value for enterprise users. If you'd like to learn more about our solution, read the API, the dev guides, download the SDK, please visit our website. Thank you.
We have time for a couple of questions.
There are people who say that enterprise blockchains are not blockchains at all. What would be your answer to them?
So I think that some of those sentiments come from the fact that enterprise blockchain is so very different than public blockchain. And because of that, there are different constraints and different control that you are okay to give to the participants that you would not be okay with in a public blockchain. I think that we know that this fundamentally is the same technology or roughly the same foundation, but as we see, it takes very different shape when you apply it to a public blockchain and an enterprise blockchain. And so I do consider this a blockchain, although I can understand where it's coming from.
What's your view on the existing enterprise blockchains and how they're solving for privacy?
How they're solving for privacy?
Yes.
I think this is like one of the final pieces of the puzzle that they're all working to see how they preserve. As the hype around blockchain started, many recognized the possible benefits in using this, and then they rushed to work on this, and then they realized that there's a problem with the fact that there's no transactional privacy, and they're looking at different angles to support it. The leading method right now seems to be zero-knowledge proofs, and so we want to help them to put that final piece in the puzzle.
Just to follow up on that, so specifically, a Hyperledger Fabric has support for tokens and also zero-knowledge. Could you compare your system to what's available there?
Sure. So first of all, I will say that our solution is blockchain agnostic, so it can work with different types of blockchains, including Hyperledger. I would say that I'm not sure that I'm fully familiar with all the different solutions that are to date, but the ones that I have seen may provide privacy using channels or encryption in trusted circles, but that still leaves the problem of what happens when you want to transact with someone outside of your channel or outside of your trusted circle, and then you need to either trust the people in the circle to verify that this is valid, or that you need to open up your books and say, here, you can see that I am really the owner of this asset. So this is one of the directions that we're taking, and we're suggesting a solution that is based on zero knowledge that does not require specific circles of trust.
Okay, we have time for one more short question.
So you mentioned that you avoid double spending by tokenizing each asset.
Mm-hmm.
So what about some digital assets like film videos or music audio clips that you want to resell the same thing while ensuring the ownership assurance and also preventing counterfeits of such asset? Is that a valid use case in your scenario?
Yeah, we can. So one of the first efforts when we approach, when we talk with the customer, is trying to understand how we model the problem using tokens, using issuance, who are the different players. So it does require more thought, but it could be represented as well. You could have unique assets or unique identifiers for each type of song or movie, and the fact that it's non-fungible, but it's not unique. So I can issue the same song or the rights to play the same song for different participants, and they cannot split it or add more of it, but still keep the uniqueness of each one. But each case does require some thought about how we model this using tokens.
Okay, great. Yeah, thank you for sharing these great applications of ZKP.